Hello everybody. Today my team and I will be sharing about our experience in the RCAP 2022 Coast Base Rescue competition. This is my team.
I'm Yu Hizou.
I'm Rafael Lim.
And I am Ho Han Wing. We have had some prior C++ experience and were participants in the previous Coast Base competition, making our current participation much more enjoyable.
The category is RCAP Coast Base Rescue U19. We are supposed to call our robot to collect objects of different color and deposit them and gain points. While collecting objects, we need to avoid obstacles, traps, and also not go out of the border. Every complete set of red, cyan, and black deposited will spawn a super object, and for every 2 sets deposited, a super plus object is produced.
Some strategies that we use includes trigonometry. We use trigonometry to find the angles we had to turn in order to face a destination. By using the a10 function, as well as our current x and y coordinates and the destination's x and y coordinates, we also made it such that superplus objects will only be collected nearing the end of the run. And we made an integer function to return an index, indicating the nearest deposit zone with reference to our current location. We also included zoning to increase the odds of encountering an object. In the end, we managed to score 2,270 points by analyzing the map and creating different zones in order to collect objects more effectively.
One concept that we are particularly interested in is our use of trigonometry during the competition. We used trigonometry to give a rough estimate of the coordinates of different zones that we had wanted to go to and superplus objects. This allowed the bot to easily pathfind to the super object/object congested zones. Since we were able to pathfind to the object congested zones, we were able to make a set much more easily, and we were able to spawn many more super objects at a much faster rate, allowing us to gain more points. We were also able to directly pathfind to the super object instead of aimlessly wandering around the map till we found it, thus boosting our score even higher. In the end, this strategy paid off and yielded us 2270 points, which was very high compared to our previous runs which incorporated other strategies.
The first picture is a picture of our final score and our best score during the preliminary round. The second picture is also a picture of one of our highest scores, which is actually one of our first runs after we finished debugging our code and got it to work well. In the game, our bot pathfinds into various zones of different color objects and collected 2 of each. It then deposits the 2 sets of different color objects and spawns superplus objects. This is repeated 3 times before the bot goes around to collect the 3 superplus objects and deposit all 3.
From our experience, we have learned a few points which we can carry on to the real world. First of all, zoning. In Coast-Based Rescue, we use zoning to collect objects more effectively. By creating a zone around an area with a high number of objects and staying inside the zone, we manage to collect more objects. This can be applied in real life with practices such as zoning for housing and work distribution, which is a common practice done nowadays. By zoning land into areas suitable for housing or farming, land space can be used more effectively. Secondly, time management. We use time management to collect plus objects more effectively. By pathfinding to superplus objects only nearing the end of the run, instead of constantly collecting one right after it's spawned, we manage to make use of time more effectively.
Number 3, pathfinding. In order to collect super objects quickly during the competition, we had to pathfind to the general area of the super object. This significantly decreased the time spent on searching for superplus objects. The bot we are tasked with programming during Coast-Based Rescue is a search and rescue bot. In the real world, bots similar to the one in Coast-Based Rescue are used to help rescue survivors. In a life and death situation, every second counts, and the bot should have a goal to immediately reach the survivors, thus showing how pathfinding can be incorporated into the real world. Thank you for listening.